Okay, this is just some graphing I talked about in the last video on number 33. We had a situation where because of the period there was no solution, so I just wanted to show you how this kind of graphs out. Remember, the period was going to be 3 pi, and we wanted to know whether this was going to be equal to -1. And there was no solution in the domain of 0 to 2 pi, so let's take a look at this. So here's how we put them in the calculus, the graphic calculator. And you'll use these a lot in calculus. So this is a sine of 2/3 x. We don't have a theta, so call this x. And then this is -1. So when we graph this, this is what it looks like. This is actually the curve, okay? Sine of 2/3 theta. Okay, and this is the -1, so this is where they're equal. So this is the value where they're equal. But if you put a trace on this and take a look at it, you can see that this point here is 6.28. Now pi is 3.14, so that's actually 2 pi. But since the period is 3 pi, see, this is 3 pi over here, and 3 pi that's about 9, because pi is 3.14, so that's 9. Probably 0.42, and you can see there's about 9.42 right over there. See, that's 3 pi. That's one period. So this is 2 pi. So you can see that I haven't got down to -1 yet. So there's no place from 0 to 2 pi that this actual function is equal to -1. It's not equal to -1 until we get after 2 pi. So there's no solution in this interval. All right. There is a point where it's equal to -1, but not in this interval. It's a little bit after this interval occurs. So hopefully that will make some sense. And let's get on to number 35 here. And we have a secant. Okay, the secant of 3 theta over 2 is equal to -2. And in these equations, I don't even want to deal with the secant because I don't like to draw that graph. I've got to draw the cosine graph anyway to draw the secant graph, so I'm just going to change this to be, say the secant is the same thing as 1 over the cosine, so I'm just going to change it. And then if I put this on top and this on the bottom, I get 1/2 negative equals the cosine of 3 theta over 2. So I can say that the cosine of 3 theta over 2 equals -1/2. Okay, so let's find the period of this. So the period is equal to 2 pi over b for the cosine. Now remember, we're on the interval 0 to 2 pi still. So that's our domain. We stick to domain. So 2 pi over b, which is 3/2. So if I invert multiply, that's going to be 2 pi times 2/3, which is 4 over 3. So that's the period, 4 over 3 pi. So we'll go through one complete period in this domain, because 4/3 is less than 2 pi. Actually, 6/3 is 2 pi, so I might even get a little bit more. Okay? So this is what we're going to have to keep adding to these different values. Now we got two possibilities. Remember, if the cosine of something equals -1/2, that's going to be, remember, the cosine of just +1/2 is pi over 3. Or the cosine of pi over 3 is +1/2, so this is going to be the negative. So this is going to be 3 theta over 2 will equal, and the cosine of what is -1/2, well, it's going to be whatever much is into the negative quadrants for the cosine, which would actually be the quadrant 2 and quadrant 3. So quadrant 2 is 2 pi over 3, and then 3 theta over 2, and the third quadrant where it's negative is also, it's going to be 4 pi over 3. So those are the two quadrants. So those are my two. Well, first of all, I got to solve for theta. I don't want 3 theta over 2, so I'll multiply both sides by, well, I can just multiply by the reciprocal. Okay, 2/3, 2/3. So I end up with theta equals, And then, doesn't really do much over here because I end up with 4 pi over 9. Okay, and here I end up with theta equal 8 pi over 9. Okay, so those are my two basic angles, but then remember, we have to add a period to each of these. These are my two basic solutions, pardon me, and I have to have a period to each. Have to add a period to each of these, and the period is 4 pi over 3. But I want to make it into 9 so it's easier to add. So if I multiply the top and the bottom by 3, that's the same thing as 12 pi over 9. So that's one period. So I'm going to kind of add these, and as long as I stay within the range of 2 pi, which is what, that's the same thing, 2 pi equals 18 pi over 9. As long as I don't pass this, I've got good solutions. So this is this is smaller than 2 pi, and this is smaller than 2 pi. Okay, so let me add this. So let me say what's 4 pi over 9 plus 12 pi over 9 to get another solution, and that's going to be 16 pi over 9. So that's good because that's still less. Okay, now let's take this one and we'll add a period to that and see what happens. So we'll say 8 pi over 9 plus, again, 12 pi over 9. But 8 pi plus 12 pi is 20 pi over 9, and that's bigger than 8 pi, so that's not going to work. That's outside my domain. So my only three solutions that are inside my domain, 0 to 2 pi, are my two basic solutions that are within the 4/3 pi domain, and then this one, but not this one. So those are your three solutions. And if you put them in order, that's what you got. 4 pi over 9, 8 pi over 9, and 16 pi over 9. And that's all you've got, because you left. When you add another period to this one, you get outside the domain. Here you can add a period to that and get the next cyclic value. Cyclic value, yeah. Or next periodic value. Here, to get the next periodic value, it's going to be outside the domain. Okay, so I hope that makes sense. These are kind of fun, but they take a while to figure out, and I guess that's even harder to explain. So you just have to practice these, and then you get the knack. But not real easy. Not real easy for the first time. These are pretty challenging problems. Okay, this book has no mercy. Okay, here's the number 37. And this is the sign. This one looks a lot different. The sign of 2x plus pi over 6 equals 1/2. Well, that's nice than 1/2. Okay? So let's try to figure out the period of this thing first. Now, there's a 2 in front, so it looks like the b is going to be 2. Now remember, if we put this in our standard form, we could write this as, we could think of this as, we take out a 2 and we'd have the sign of 2 times, because we just want an x there. All right? And if I write this as 2 pi over 12, that's the same thing as pi over 6. If I take the 2 out, I end up with pi over 12. In other words, if you multiply that, you get 2x plus pi over 6. So basically, we have a pi over 12 shift to the left. But we still have a 2 in front. So the period, which equals 2 pi over b, over 2 in this case, because my b is 2, is equal to pi. So I have a period of pi. So in my domain, remember my domain is 0 to 2 pi, I'm going to have 2 periods. Okay? Which means I'll probably have 4 answers, 2 for each of the quadrants. Okay? So remember, if the sign of something equals 1/2, that something would be, well, the sign of pi over 6. Okay? So I would say that 2x plus pi over 6 equals, and the sign of pi over 6 is 1/2, so that would be pi over 6. And then also, in the second quadrant, because it's also positive, so I'd have to say over here, 2x plus pi over 6 equals 5 pi over 6. All right? So those would be my two basic answers. But then I would have to add a period to each of those. All right? But first of all, I got to find out what x is, because I'm sorry, I don't want this. So first of all, if I subtract pi over 6 from both sides, I get 2x equals 0. So x equals 0. All right, so that's one basic answer, is x equals 0. And then the other one here would be 2x equals, and then if I subtract pi over 6, I get 4 pi over 6. And then if I multiply by 1/2 to get rid of that 2, oops, that's 4 pi over 6, pardon me. Then 2 goes in there twice, so that's the same thing as 2 pi over 6, which is pi over 3. Okay, so those are your two basic answers. Okay, now remember, that's the first ones that occur, but we're going to have two periods, so we'll have another periodic point where this is going to be also valid. This will also be equal to 1/2. It's going to be equal, periodically. All right, so we got another point here and another point there, and then we find that by adding pi to this. So 0 plus pi, x also equals 0 plus pi, which is just pi. And x also equals pi over 3 plus pi. And pi is the same thing as 3 pi over 3, right? That's just pi. I did that so I can add those, and I get 4 pi over 3. So those are your 4 basic solutions. Like that. So if you write a solution set, you get 0, pi over 3, pi, and 4 pi over 3. Okay? So I hope that makes sense. There's a lot of intuition involved in these by just adding the pi's to get the next periodic value, or the next cyclic value, because what's going to happen, because it repeats it, it comes another period later, but we just add whatever the period is. And in this case, we have to find out what the period is, so it's going to be pi, so we just add a pi to that, and we get the next answer. We add pi to that, we get the next answer. Now, these are all within the domain. Now I can add pi to that, but then I get 2 pi, and that should be open. Shame on me. It's like this. So if I add another pi to that, I get 2 pi, and if I add another pi to that, I get way out. So that's why I just have these 4 solutions. Okay? All right, so that's that. So pretty challenging problems. Try to think about them and acquire some intuition about this stuff. Hope that helps.